All right, so cool stuff, right? But you're wondering, what do I actually have to know? So you got to know why double and triple bonds can't rotate. And then another thing you need to be able to do is identify the hybridization. And so this is something that becomes much more important when you get to higher levels of chemistry, such as OChem. So let's just take a look at these. Remember, we only do non-terminal atoms. We don't assign hybridization for terminal atoms. So if we take a look at this nitrogen, it has 4 things attached to it, 3 atoms and 1 lone pair, so it's sp3 hybridized. If you take a look at this carbon, it's got 4 things or 3 things attached to it, right? Just 3 atoms, so that's sp2 hybridized. If you take a look at this oxygen, it has 4 things, so sp3. And then if you take a look at these 2 carbons, they each have 2 things, so both of these are sp hybridized. So that's one thing you'll be asked. Another thing you'll be asked is how many sigma bonds there are, and then how many pi bonds there are. Remember, sigma bonds, it always starts with a sigma bond for a single bond, and then anything beyond a single bond is a pi bond. So when you think about how many sigma bonds there are, all you have to do is count how many single bonds there are. So 1, 2, 3, one of these, that's 4, 5, 6, only one of these, 7, and then 8. So there's 8 sigma bonds in this molecule. And then pi bonds are your double and your triple bonds. So there's 1 right here from this C double bond O, and then 2 and 3 from this C triply bond to this other carbon. So there's 3 pi orbitals. So just to kind of wrap things up, valence bond theory kind of mixed in with hybridization explains double and triple bonds. And then it's going to build the foundations of molecular orbital theory, which we'll be going into next. And valence bond theory and hybridization is something that's much more used in higher levels of chemistry, such as organic chemistry. In our class, we'll mostly stick to Lewis and Vesper.